Guys, Mr. Gucci here doing the last few homework problems for you right now. Okay, so this is number 16, 17, and 18. This involves us looking forward to where we're going to be going in this section in the next couple days. All right, and so you might have noticed as we were filling out these orbital electron configurations, all right, it's real annoying to have to draw all these arrows every single time. Wouldn't it be great if there was an easier way to write the electron configuration? Well, there is. There is an easier way, and it's called the written configuration. And it's super simple, okay? Super simple. Here's how it works, okay? So we're going to write the same kind of configuration up here, but instead of writing little arrows above, let's write 1s. Instead of writing little arrows above it, we're just going to write a little number right above the S that indicates how many electrons are there. So there are 1, 2 electrons here. So up and to the right, we're going to do 1s2. Okay? Then the next sublevel to come along is the 2s, which also has 2 electrons in it. So 2s2. All right? Then comes the 2p. 1, 2, 3, 4, 5, 6. There's 6 electrons here. So it's going to be 2p, or not 2p, no, but seriously, 2p, 6, because there were 6 electrons in that sublevel, okay? And after that comes the 3s and the 3p. The 3s has 1, 2 electrons, and now the 3p has 1, 2, 3 electrons. 3p, 3. All right, this is important, okay? You're not just writing the number of how many electrons could fit. You're writing down the number of how many electrons are there. Okay, so the reason it ends with a 3p3 is because there's only 3 electrons there. Okay, and so that's it. 1s2, 2s2, 2p6, 3s2, 3p6. That is the written configuration. Much easier than writing all the arrows. Let's try another one. Chlorine, an element with 17 electrons. Okay, now I'm going to skip the color coding. I'm just going to write it down, okay? So we got 1s, and there's 2 electrons. We've got 2s, and there's 2 electrons. We've got 2p, and there's 1, 2, 3, 4, 5, 6 electrons. We've got 3s with 2 electrons. All right, that's Pauli exclusion principle. You can only have 2 electrons fit in each of these orbitals. All right, not 3. All right, lastly, 3p. 1, 2, 3, 4, 5. Once again, we end with 5 electrons in the last sublevel, so we end with a 5 right there. Now, I've been writing this by hand. Maybe you're wondering, Mr. Gucci, how do I type this? It is, in fact, quite easy, okay? So I'm going to type in 1s2, and I am going to highlight that 2, and I am going to go to, let's see here, home. I have a button right here that just turns it into a subscript, okay? I have that button. You are going to have to go into Format, Text, Subscript. So it's different in the sheets here. Let's take a look here. All right. Yeah. So let me just blow this up for you real quick, show you how you would do this. Okay. So for this one down here, when you were writing it in, you would go like, all right, 1s2, all right, and you would, and then 2s2, and then 2p5, right, and then you would highlight this, and you would go to Format, Text, Superscript, highlight, and go to Format, Text, Superscript, highlight, go to Format, Text, Superscript. All right, that's how you do it. Format, Text, Superscript. Okay, so slightly different for you than for me. All right, for me, I can just highlight and I can click the little Superscript button right there, and that takes care of it. All right, so I'm going to go 2p6, 3s2, 3p5. Okay, and I'm just going to highlight all those things that I want to make superscript, and bam, I'm going to do it. Has to be superscript, guys. Has to be superscript. It can't just be, a number. Has to be superscript like that. All right, cool. All right, last one is sulfur. All right, last one is sulfur. And so the electron configuration for sulfur is 1s2, 2s2, 2p6, 3s2, 3p, 1, 2, 3, 4, 3p, 4. Okay, that is the electron configuration for sulfur. Okay, and again, since we have 1, 2, 3, 4 electrons here in the last sublevel, we end with a 4 because that's how many electrons are in that sublevel. Okay, let's do a big one from front to back, from beginning to end. Okay, cobalt. Let's do cobalt. Let's write the orbital configuration, then let's do the written configuration. So cobalt, I go to the periodic table, I look up cobalt, element CO, and I see that it is 27. It is element number 27. So it's got 27 electrons. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now all the urinals are filled. We got to double up. 26, 27. That is it. That's it. That's done. All right, that's done. That is the electron configuration in orbital style. All right, orbital style. Now let's do the written configuration. Okay, we've got 1s2. We've got 2s2. We've got 2p, 2, 3, 4, 5, 6. 2p6, 3s2, 3p6, 1, 2, 3, 4, 5, 6. We've got 4s2, and we've got 3d, 1, 2, 3, 4, 5, 6, 7, 3d, 7. And once again, there are 7 electrons here at the end, which is why we end on 7. Okay, cool. Now that's it. Now I didn't really talk about this in class, but guys, it's pretty straightforward. I think just by looking at this video, you can, maybe not even, maybe just looking at the example, that's enough to get a handle on this. Okay, you will do just fine. And there's a bonus question here where I have you try and figure out what's the electron configuration of a nitride ion, a -3 nitrogen ion, which is going to be interesting because it's -3, and so it does not have the same number of electrons as a normal nitrogen. Figure out how many electrons a regular neutral nitrogen has, and then ask yourself, ooh, how many more or less electrons does it have to have a -3 charge? And then do that configuration. Okay, guys, that is all the homework help videos. I hope this will help. I wish you luck. Bye.